Chapter 3 Force and Motion. After studying motions in terms of simple measurements such as displacement, velocity, and acceleration, we will start to investigate the effect of applying a force to a mass to set it into motion. Chapter 3.1 Introduction to Forces. 1. Some basic understanding about forces. Force is measured in Newton. In particular, a mass of about 100 grams produces a weight of 1 Newton. Force is a vector with magnitude in direction, which can be represented by an arrow. By Newton's third law, which you have learned in S2, you know that forces exist in pairs, so-called action-reaction pairs. In a laboratory, we use a spring balance or use a force sensor connected to a data logger to measure forces. 2. Daily life examples of forces. There are contact forces and non-contact forces in daily life. Pushing and pulling are contact forces. Contact forces include friction between objects, tension in a string, and normal force provided by the surface. 1. Friction. There is friction between two surfaces when they have a relative motion, such as sliding, or when there is just a tendency of motion. The friction acts on the surface always tries to oppose the relative motion of the surfaces. Say, in this case, there is a table which is pulled by the man to the left. So there will be a friction acting on the table by the ground to the right-hand side. But at the same time, there will also be a friction acting on the ground by the table to the left. However, friction does not always oppose the motion of an object. For example, friction is on our feet when we walk results in forward motion of our bodies. Let's take the example on the right to illustrate the idea. When he walks, then he will push his boot to the back. There will then be a friction acting on his boot forward, and this friction will actually pushes the boy to move uphill. On the other hand, there is also friction acting on the slope by the boot in the backward direction. If you look at the friction acting on the boot, the friction will try to stop the motion of the boot, but at the same time, the friction provides a forward force for the boy to walk uphill. 2. Tension. Tension is the force developed in a piece of string or in a spring when it is stretched. The two objects at the ends will experience pulling forces towards each other. Note that the tension is the same along the stretched string or spring. In figure 3.1g, the spring balance shows a reading of 10 Newton, but not 20 Newton when the two hands each experience a pull of 10 Newton. 3. Normal force. Normal force is a push perpendicular to the surface, as on an object when the object is in contact with the surface. Normal force is also called normal reaction force, or simply normal reaction. In other words, when an object is in contact with another and exerts a contact force in form of a push, then the normal reaction will be produced. Simply speaking, normal reaction force is the result when an object pushes on a surface. B. Non-contact forces. Non-contact forces include weight, electric, and magnetic forces. In these cases, the two objects which interact do not touch each other. 1. Weight. Weight is the name given to the gravitational attractive force on a mass by the Earth. It is a pulling force towards the center of the Earth. The gravitational attraction acts on an object even if the object is in mid-air. Two, electric and magnetic forces. Electric force exists between charges, while magnetic force exists between magnetic poles. There's even electromagnetic force exists between magnetic field and moving charges. Weight and electric and magnetic forces are non-contact forces, as they may act at a distance without objects touching each other. 3. Free body diagrams. A free body diagram shows all the forces acting on an object. In a free body diagram, there should be one mass only. If the mass is a combined object, then all the internal forces should not be shown. Four, net force. Net force is also called resultant force or unbalanced force. On page 10 and 11, you have learned how to find the resultant of displacements, which are vectors. So we may also find the resultant of forces using similar technique, as forces are also vectors. In the following cases, the right is positive convention is adopted. Forces that point to the left are given a negative value. The sum of forces is simply the sum of those vectors, such as 2 plus negative 2 in the second case, which gives 0 resultant. And it is 4 plus negative 2, which gives positive 2 Newton for the third case there, which means a force of 2 Newton points to the right.